Hello, in this video I will integrate integrals using the U-substitution method. I will use bounded and unbounded integrals. So this is all about an introduction of U-substitution. The objective after the video, you should be confident to integrate using a U-substitution method. So on this video, we're just going to do unbounded. That means our final answer will have a plus C. Okay, and then I think the next video will do on some unbounded. Okay, so let's move on. Oops. Okay, so what is U-substitution? It's just one of the several techniques of integrating integrals with bounded and unbounded integrals. Okay, so basically it's just the area under a curve. We won't go over Riemann sums. These are just all different methods. So what are the steps in U-substitution method? Okay, so first step is figure out your appropriate U-substitution. So that's kind of like always the hardest part. You have to figure out what your U will be. Step 2, take U prime or du dx, and I will explain that in the video. So once you found your U, you take the derivative of that. Step 3, remove anything you don't need. So I will explain that when we do an example. So once you have your U, then you have your U prime, you get rid of anything you don't need. Step 4, continue with integral rules. If integral is unbounded, make sure you add the plus C. Yeah, and then if the integral is bounded, you apply fundamental theorem of calculus. You do not need to add the plus C if the integral is bounded. Okay, so let's start with example 1. So we have to integrate 2x parentheses x squared plus 1 raised to the 23 dx. So the first part is to figure out what is my U. And I'm going to say that my U will be the inside parentheses x squared plus 1. And then you'll see why. Then I would take my U prime or du dx. So I'm taking the derivative of U in respect to x. So I'm going to show you here, I'm going to say du dx for right now, and then in the other videos I won't add the dx, and I'll show you why. On the right, so you're taking the derivative in respect to x. So what's the derivative of x squared in respect to x? It would be 2x. And then what's the derivative of 1 or a constant? It's 0. Okay, so on the left you have du dx, and then on the right we just have 2x. The thing is, this is our u now, and then we have this extra 2x and this dx. So on the right side of this, we have only 2x. If I have a dx, it would actually turn out really nice. So I'm going to get rid of this dx or move it to the right by multiplying both sides by dx. So I'm only going to do this once, and then I won't do it in the other examples. So on the left side, you have du, and then on the right, you have 2x dx. Okay? So my u is x squared plus 1, and then my u prime or du is 2x dx. And you'll see why I did it, brought the dx. So we're going to rewrite this as, we can replace x squared plus 1 with u. It's still raised to the 23rd. Oh, and then one of the last step, I think rule step 3 is get rid of anything we don't need. So we don't have to get rid of anything because you'll see it comes out nicely. We have this 2x and then this dx, which is exactly what we have on the right side, right? We have a 2x and a dx, so we don't have to get rid of anything. Sometimes you will, sometimes you don't, but in this case we don't. Now, did you know that you can substitute, we have a 2x and dx, that equals to du. So did you know that you can replace 2x and dx with du, right? Okay, so see how everything is in terms of u? That's how we have to make sure everything, if everything is in terms of y, we have to make everything in terms of y. If everything is in terms of x, we have to make sure everything is in terms of x. So that is why that's why I replace this 2x dx with du. Okay, and then continuing the rules, we continue with the integral. So what is the integral of u to the 23? It is, it's just simple integration rule. It would be 1 over 24 u to the 24, right? So it's 23 plus 1, which is 24. So that's why you put it in the bottom. And then your new power is 23 plus 1. And then don't forget the plus c, because we have no boundaries. And then finally, you can replace u with x squared plus 1. So your final answer would be 1 over 24, parentheses, x squared plus 1 raised to the 24 plus c. Okay, so that's what I did. So figure out your u, take the du dx, or take u prime, and get rid of anything you don't need. In our case, we didn't have to get rid of anything. And then take your, continue with your integration rule. Okay, let's move on to, go ahead and pause if you need to. I'm going to move on to example 2. Okay, example 2, integrate. We have the cosine cube x times sine x dx. So first step is to figure out what is your u. Did you know you can rewrite this problem as this cosine cube of x is equivalent to saying cosine of x raised to the third power times sine x dx. I don't know if that helps, but you can rewrite that problem as this. And then we're going to figure out what my u is. So what do you think my u is? I don't think it's going to be sine x, because if you take the derivative of that, you're going to get like cosine x, but we still have this power 3. So I think my u is going to be cosine x. And then du would be negative sine x dx. Okay, so you're probably thinking, how did this dx come to the right? Well, I kind of like did one extra step, right? So on the left side, what is the derivative of u in respect to x? It's actually du dx, right? And then on the right, what's the derivative of cosine? It would be negative sine x. Negative sine x. Then what I did was I got rid of this dx by multiplying dx. So that's why on the left side, it was just du equals to negative sin of x dx. Okay, so I just note, I'm not going to do, I'm not going to always do this. I'm not going to say du dx and then multiply both sides by dx. I'm just going to say the right side has a dx. Okay, now this next step is get rid of anything we don't need. So we have a sine x, and then we have a dx. So on the right side, we have a sine x and a dx, but we don't need this extra minus or this negative 1. So we're going to have to get rid of it. So how do we get rid of this negative 1? By multiplying both sides by negative 1. So multiply the left side by negative 1, multiply the right side by negative 1. So on the left side, you're left with negative du And then on the right, -1 times -1 is positive sin x dx. Okay, it's everything that we need because we have a sin x dx, which is perfect. So now let's start integrating. So we can replace cosine x with u because that's what we said. So it's going to be u to the 3. And then what are we going to replace sin x dx with? So we said that sin x dx is actually -1 du. So you can replace sin x dx with -1 du. Do not just say it's du. Okay? And then continue with integration rule. So did you know that -1 is a constant? So what you can do to make your life easier is move the constant on the left side of the integral. So let's move this -1 to the left. So it would be -1 here. And then it's going to be u cubed du. Okay? And then just continue on with the integration. Well, so what's the integral of u to the 3? It's u to the 4 over 4. And then you still have to distribute this -1. And then don't forget the plus c. So let me put it right here. I'm running out of space. So this is going to be -1/4 u to the 4 plus c. And then just substitute your u with cosine x. So it'd be -1/4 cosine of x to the 4th power plus c. Okay, so that's your final answer. So in this example, the only thing we had to do is get rid of this -1 by multiplying both sides by -1. Okay, let's move on to example 3, or if you need to pause, go ahead and pause the video. So example 3 says like, integrate, and then we have 1 over square root of x, 1 over square root of x times sin of square root of x dx. If you want, this sin could be in parentheses. That makes it easier. So what do you think our u is going to be? Go ahead and just try it, figure it out. But I think our u is going to be square root of x. And then what would be my du? So basically the square root, what is the derivative of square root of x? It is 1 over 2 radical x dx. Okay. If you forgot how to take the square root of x, basically I just wrote square root of x as a power and take the derivative of that by applying power rule. Okay, so if you look at our problem, we have this radical x, and we also have this 1 over radical x, so this is good. The only thing is we have to get rid of this 2 because we don't need a 2 in our problem. We don't have a 2 anywhere in our problem. So let's get rid of that 2. And how would you do so? By multiplying both sides by 2, right? So on the left, it's 2 du, and then on the right, 2 times this, the 2's cancels, right? And then you're just left with 1 over radical x dx. Okay? So it's going to be 1 over, and then just replace x square root of x with u. And then we can replace no, whoops, my bad. Made a mistake. Let's do the sin thing. It would be sin, replace square root of x with u. And then we can replace 1 over square root of x dx, right? 1 over square root of x dx with 2 du. Okay, that's much better. Then continue with the integration rule. So this 2 is a constant. So what we'll do is put the 2 in front of the integral. And now you're left with sin of u du. And then continue with integration rule. What is the integral of sin u? It is negative cosine of u. And then keep in mind, we still have to multiply this by 2. And then don't forget to add c. Let me put it here. So you get 2 times this is negative 2 cosine of u plus c. And then just replace your u with radical x. So your final answer will be negative 2 cosine parentheses square root of x plus c. And that is your final answer. Okay, so go ahead and absorb, write down, or pause, because I'm moving on to the next example. Example 4. So we have the integral of 3x over square root of 4x squared plus 5 dx. So we got to figure out what do you think our u is. I'll just give you a clue. The u is always the complex one. So what is more complex, the 3x or the 4x squared plus 5? The 4x squared plus 5. Okay, and then take the du. So what's the derivative of 4x squared? 8x. What's the derivative of 5, or a constant? 0. And then don't forget to add the dx. Oh, there's one more thing I should have done first. Do you see this 3 right here? That is a constant. So if you have a constant, make sure you can always put it outside the integral. That'll make your life easier. So put that 3 outside, and then this is going to be x square root of 4x squared plus 5 dx. Now that's a lot much easier. And the u is still, I believe the u is still going to be 4x squared plus 5. Okay, so now we have an 8x dx. Is there anything we need to get rid of? Yes. We have this x and this dx, which is what we have here, but we don't have this 8. So I'm going to get rid of this 8 by what? By how? By multiplying both sides by the reciprocal of 8. What is the reciprocal of 8? 1 over 8. So on the left, what's 1/8 times du is 1/8 du. And then on the right, 8 times 1/8 is just x dx. Perfect. So now it looks good. So over on the bottom, this would be square root of u. And then what you could do is, don't forget there's a 3 here. Then you're going to replace x and dx with 1/8 du. Okay. Then you have a constant of 1/8, so put it outside. So don't forget you have a 3 here. So you still have to multiply that 3 by the 1/8. So 3 times 1/8 is 3/8. So put it outside here. And then you have a 1 over square root of u du. Okay. And then let's rewrite 1 over square root of u as a power. So I know that square root of u is u to the 1/2, but it's in the bottom. So it's going to be written as u to the negative 1/2 du. Okay, and then just take the integral of u to the negative 1/2. So how do you do that? You you just use your integral rule. So you add 1. So what's negative 1/2 plus 1? Or in our case, 2/2. That would be u to the 3/2. And then you divide that by that power. So u to the 3/2 divided by 3/2. What is that going to be? Whoops, I made a mistake. What's negative 1/2 plus 2/2? 1/2, not 3/2. So this should be u to the 1/2, and then this should be divided by u on 1/2. So if you want, you can rewrite this as u to the 1/2 divided by 1/2. And then cross multiply, so that's 2u to the 1/2 over 1. And then don't forget that you still took out this 3/8, so multiply this by 3/8 and then add the plus c. So 3/8 times 2 is 6/8 u to the 1/2 plus c. And then 6/8 can be reduced by 2. So this is 3/4. So your final answer should be 3/4. U to the 1/2 is the same thing as square root of u, and u is what did we say u was? U is 4x squared plus 5. And then don't forget the plus c. Okay, go ahead and absorb, pause, and write. Because I'm moving on. Okay, let's move on with example 5. So we have the integral of secant square parentheses 4x plus 1 parentheses dx. So my u is always the more complex one. So I'm going to say u as my 4x plus 1. Du would be the derivative of 4x is 4. The derivative of 1 is 0. And then don't forget you add dx on the right. So is there anything we don't need? Yes, we don't need this 4 because we have a dx here, and then this is like 1. So let's get rid of this 4 by multiplying both sides by the reciprocal of 4, which is 1/4. So this is 1/4 du, and then this is dx. So it's going to be integral secant square, and then you're going to replace 4x plus 1 with u times so you can replace this dx or this 1 dx with 1/4 du, right? And then 1/4 is a constant, so take it, put it outside the left of the integral. And then what is the integral of secant square u? That's one of your special ones, and that is tan of u. And then still multiply this by 1/4, and then plus c. Okay, so your final answer is going to be 1/4 tan parentheses. We said our u was 4x plus 1 plus c. And that's it. That's your final answer. Okay. I think there's, let's see, 3 more. So far, these are technically like easier examples of U-substitution. They can get a bit more complex, but I just want to just introduce you to U-substitution. So that's why on this video, it's simpler ones. Example 6. Ah, I don't know why I can't go to the next slide. There we go. Okay, example 6. So we have the integral of y square root, integral of y times square root of 1 plus 2y squared dy. So now we're on like in y. So what would be my u? It's always the complex one. So I'm going to say my u would be 1 plus 2y squared. And then I'm going to du. The integral of 1 is 0. The integral of 2y squared is 4y to the 1. And then instead of dx, it's going to be dy. Because we're in like terms of y. And is there anything we don't need? We don't need this 4, right? Because we have a y and a dy, right? So these two are good. I just have to get rid of this 4. So to get rid of this 4, I'm going to multiply both sides by the reciprocal of 4, which is 1/4. That's 1/4 du. So it's going to be y dy. Okay. So this is going to be square root 1 plus 2y squared is u. And then you're going to replace y and dy with 1/4 du, right? And then 1/4 is a constant. I mean, yeah, a constant. So put that 1/4 on the left of the integral. So that'd be 1/4 square root of u du. And then continue with the integration rule. So if you want, you can rewrite square root of u as a power as u to the 1/2 du. And then what is the integral of u to the 1/2? So you just basically add 1 and then divide that, whatever that power is, you divide that power with that number. So what's 1/2 plus 1 or 2/2? It would be 3/2. So it would be u to the 3/2 divided by 3/2. When you simplify that, that gives you 2/3 u to the 3/2. And then remember, we still have this 1/4. So we're going to multiply both sides by 1/4. And then don't forget the plus c. Put it all together, you get 2/12 u to the 3/2 plus c. And then 2 to the 12s can be reduced by 1/6 u to the 3/2 plus c. And then just replace your u with 1 plus 2y squared. So your final answer will be 1/6 parentheses 1 plus 2y squared raised to the 3/2 and then plus c. Okay, that was example 6. 2 more examples to go, and then we'll do like medium hard examples. So moving on to example 7. So example 7, we have integral of square root of sine parentheses pi theta times cosine pi theta. So this one's a little bit trickier. What would be my appropriate u substitution? I don't think it's gonna just be pi theta. I think it's gonna be the inside, everything inside the square root. So if I do that, my u would be sin of pi theta. And then du. So how do you take the derivative of this? This one, you have to apply the chain rule, right? So first off, what is the derivative of sin? It is cosine. And then leave the inside alone, leave the parenthesis alone. And then you apply the chain rule by basically taking the derivative of the inside. So what is the derivative of pi theta? That's a bit tricky. So pi is a constant and theta is like a variable. So it's no different than, I don't know, 5x, right? What's the derivative of 5x? 5. So that's like the same situation for pi theta. So the derivative of pi theta is actually just going to be pi. And then don't forget to add, in our case, this would be d theta, because, yeah, we're in terms of theta. So based on that, is there anything we need to get rid of? So we have this cosine pi theta, which is good for this one. And then we have this d theta. But we don't have this pi, or this pi is a constant, right? It's like 3.14. We don't have that pi, so we'll have to get rid of that pi. By how? By multiplying both sides by the reciprocal of pi over 1. So that would be 1 over pi, right? So on the left, you have 1 over pi du. And then on the right, it's going to be these pi's cancel, so you're just left with cosine pi theta d theta. Okay, so it's going to be integral, replace sin pi theta with u, and then we're going to replace cosine pi theta d theta with this, the whole thing, 1 over pi du. Okay, so 1 over pi is a constant, so you could put that outside. And then square root of u du. And then you can rewrite square root of u as a power. That's the same thing as u to the 1/2 pi du. And then what is the integral of u to the 1/2? I think we did it in one of the previous videos. That turns out to be 2/3 u to the 3/2. And then because we took out a 1 over pi, we have to multiply this by 1 over pi. And then don't forget the plus c. So when you put it all together, you're going to get 2 over 3 pi times u to the 3/2. My u is sin of pi theta raised to the 3/2 plus c. Okay, so that one's a little bit trickier one. Okay, go ahead and pause, absorb. We're moving on. Last one. Whoops, sorry. Example 8. So we have integral of 2x plus 7 parent integral times, wait, so it's integral parentheses 2x plus 7 parentheses x squared plus 7x plus 3 raised to the 4/5. So like we said before, the u is always the more complex one. So I don't think our u is going to be 2x plus 7. I think it's going to be this whole thing. And then du would be the derivative of x squared is 2x, the derivative of 7x is 7, and then don't forget to add the dx. So, oh good, like this comes out nicely because we have this 2x plus 7 and the dx, so we don't have to get rid of anything at all. So you can rewrite this as, you replace this whole thing with u to the 4/5, and then you're going to replace 2x plus 7 dx with du. Okay, and then what's the integral of u to the 4/5? So it's just 4/5 plus 1, or in our case 5/5. That would be u to the 9/5 divided by that power. So you can rewrite this as u to the 9/5 divided by 9/5. This u has a denominator 1 and then cross multiply. So that would be 5u to the 9/5 over 1 times 9 is 9. Okay, so your final answer is 5/9 parentheses u, which we said is x squared plus 7x plus 3 parentheses to the 9/5 and then plus d. Okay, that is the last example of this section. Okay, I will stop here. Thank you.